Now, for this session, I'd like to do something slightly different, and that's because time and again, in discussions about challenges in the telecoms industry, and especially when it comes to this, the phrase comes up, it's not a technology issue. So while we could do some great demonstrations with the companies in this session who are straddling the telecoms and enterprise spaces, and we'll certainly get them to introduce themselves and talk about that, I'd actually like to focus the session on what the real issues are and how we might solve them, especially based on the lessons and insights from the companies here who are doing that. Now, I mean, some of these might be technical challenges, but I would be amazed if all of them are. First of all, introductions. I'll start with our team of journalists and analysts, and then I'll get our industry speakers to introduce themselves and share a couple of observations to kick us off. And then we can take a deeper dive. And as ever, if our audience wants to ask questions or comment as we go, I'll do my best to work that into the conversation. So with that, I'd like to say welcome to Caroline Gabriel. Maybe you can just give a quick introduction to who you are and your background.
Well, thanks, Alex. Yes, I'm Caroline Gabriel. I'm a research partner at Analysts Mason, based here in London, and my speciality as an analyst over the last 25 years or so has been mobile networks, and to Alex's point, increasingly that has been focusing on what those can do to support enterprise requirements.
Thanks, Caroline. Rudolf, your turn.
Sure. I'm Rudolf Moncrief. I'm the editor and founder of Open and Disaggregated Infrastructure News. Currently a little bit on hiatus. I'm also heading up content for the TM Forum at the moment, so it's been really interesting to learn more about what's happening in the upper layers and in the core with things like open APIs, following my stint looking at Open RAN, Open Transport, and all these what I think are really exciting kind of innovations in mobile infrastructure. I've been working in telecom since 2007. I don't think I've got the same level of expertise as Caroline. It's really nice to have you here, Caroline, by the way. But I do find it really fascinating, and I definitely have some opinions. So looking forward to sharing them here.
Fantastic. And yeah, one more person who I think is not always shy of his opinions. Ian, maybe you can give a quick intro.
Hi, Alex. Afternoon, everybody, or morning, depending on where you are. My name's Ian Morris. I'm editor at Light Reading. I feel like I've been there for an eternity, but I think it's something like 10 years, but I've been in the sector since sort of 2000. So yeah, I feel incredibly old. Yeah, I'm probably covering mobile mainly, I think, these days. And Rudolf mentioned Open RAN there. That's been a sort of fairly hot topic for me. By no means I'm an expert on stuff to do with the enterprise, but it's an interesting area that's been talked about a lot, as you said, Alex. So kind of keen to see what people have to say about it.
Fantastic. Thanks, Ian. So our experts on the subject here today are James Kay and David Knight. I am hoping that we'll also have Oliver Korfmacher joining us, but we'll see how that one plays out. But in the meantime, David, perhaps I can get you to introduce yourself, give a quick background to Terbine, and share some thoughts on this issue of that challenge.
Sure. You're hearing me okay?
Yeah, thanks.
Brilliant. First of all, hello from Nevada. And I'm the token entrepreneur, I think, from the startup community. Yeah, I've been involved with starting companies, building companies. I've had 2 get acquired, 2 go public, and 2 have a mighty crash. So I've got the full portfolio of startup trophies and battle scars. What are we doing now? So Terbine, spelled with an E, which, if you're wondering, gives us the ability to have global trademarks by not spelling it conventionally. It's kind of like Google. So we're having a fantastic renaissance being driven by advances in telecommunications and AI. So what are we doing at Terbine? We are building, to borrow a term from telecom, creating an orchestration layer that will live above telco networks and other networks in the cloud to orchestrate the interaction of machines as we get into the new world being called physical AI, which the head of NVIDIA says will be worth $1 trillion going forward. And that's where you give agency to machines. They can have wheels, treads, wings, rotors, hulls, and of course legs. And something eventually has to come in and orchestrate these things. How do they interact with each other, with humans and the environments they're operating in? How do they do financial transactions as a robot, essentially? So big thing to take on. So we decided to just really jump in and focus on that. So, working with NVIDIA, starting to work with some of the telcos here in the States, but we're keenly interested in working with telcos around the world. The one thing I'll mention before I stop blabbing, the key enabler to all of this is the finally realizing the dream of mobile edge computing, where you have basically processors adjacent to cell towers so that you have a very ultra fast connection between something nearby the tower, which is probably in motion, and the processing of various things can be done at the base of the tower and sent back to the machine, or it can be transferred to another tower. And it's something I think everybody's talked about for years, but never really had, the killer apps for it. But now physical AI provides that. And since you asked me about the relevancy, there's of course quite a bit of talk right now about telcos will be replaced by low Earth orbit satellites and that sort of thing. Maybe in some cases, but the truth is you're never going to get the latency, the super low latency in processing in a satellite at the scale you need to do physical AI, very pervasively and reliably. So that kind of, gives hope for the telcos, to not worry about the satellites as an existential threat, but sort of an augmenting thing. And, again, it's a very exciting time to be doing this. And, but we used to talk about these bunkers at the base of the cell towers being full of Intel chips. They're going to be full of, NVIDIA chips. Anyway, there you go.
You're on mute, Alex.
Yeah, you're muted.
Typical. Thank you. Thanks ever so much, David.
Sure.
James, maybe we can get you to introduce yourself as well, and Dejero.
Absolutely. Thanks, Alex. So just to introduce myself, I'm James Kay. I'm the business development manager for Dejero, covering our enterprise and telecom segments. Just kind of following up on what David said, I would agree to some extent that certainly the latency that you see on, fiber optic cable networks is significantly better than what you would see on, LEO, MEO, GEO satellite connections. Certainly vendors like Starlink are becoming better from a latency perspective, getting numbers down into like the, 25 to 50 millisecond range from a latency perspective. But fiber optic cable certainly surpasses that, running anywhere between, 1 to 5 milliseconds in terms of latency and transport, which is very critical and important for powering AI, Gen AI based applications. So I completely agree with him from that perspective. With that being said, Dejero as an organization is kind of focused on sort of smoothing out some of those latencies and signals from a LEO, MEO, GEO satellite perspective, or even aggregating bandwidth from 4G or 5G connections to provide, sort of critical connectivity for Gen AI models and, retrieval augmented generation or RAG-based applications for those AI models when they need to obtain data from, external sources that may not be immediately available within the model itself. And so that's where Dejero sort of comes in. And, as you can sort of see from my background here, what Dejero really specializes in is providing connectivity that is reliable and robust in very rural or remote parts of our country, or our planet for that matter. We, as a company, started in the broadcast video industry. We've been in business for about 17 years now, focused on providing high definition video transport for the reporter, reporting on live breaking news or natural disasters. So we've been in that industry for the last 17 years. In the last 7 to 8 years, we've pivoted into public safety based applications with police cruisers, fire trucks, 911 call centers. For instance, in California, we're designed into all of the CAL OES, the Office of Emergency Services 911 call centers. There are 450 across the state. Prior to our equipment being installed there, they were seeing around 36,000 minutes of downtime as a result of issues with fiber cuts or network outages on the fiber optic cable side of their business. We installed our connectivity service that's built around the premise of multiple connections and help them reduce their downtime to 0 seconds over the last 5+ years since our equipment's been installed at those public safety answering points. We are very much focused as a company on providing critical connectivity in very rural or remote parts of the country, and are excited to be participating in this conversation with teams about how we can enable more critical connectivity for Gen AI and enterprise-based applications.
Thanks very much. Now, I don't want to be monopolizing this conversation because I'm aware that Caroline, Ian, and Rudolph tend to have plenty of questions of their own. So I'm going to take a step back and give them a minute or two if you'd like to dive in and make some questions or observations based on what you've heard.
I'll just say, oh, sorry, go for it, Caroline.
Go on, Rudolph, if you.
Oh, yeah, I was going to say, I mean, both really impressive kind of stories. I think I had questions for David, especially because in Finland, there are a lot of these little robots that do deliveries from supermarkets, and they've been around for a couple of years, and they even have drones, like the flying ones. So they've got like little robots on wheels. Because Finnish people don't typically like to, they shy social interactions. But James, I thought you said something that I thought was really, really interesting. Is because connectivity is kind of premised on scale. And that's been the kind of driving force behind what pays for the technology and the upgrades and all these kinds of things. But you're specializing, and I think one of the big, I totally agree on the satellite thing. It's really for those areas where there aren't that many people. But there's a problem, given that the urbanization that we're seeing in the world, like 3 million people, I think, a week are moving into cities. By 2045, I've read a stat, 65% of the population is going to be living in cities. How do you reconcile that with your business model, providing like really critical infrastructure connectivity in places where there are going to be over time fewer and fewer people?
Yeah, great question, Rudolph. I think from Dejero's perspective, we're not necessarily targeting consumer-based applications. So LEO satellite connections like Starlink, for instance, provide a great service for residential homes or golf courses. If the internet connectivity drops out for a period of time, the residential user, it's just a matter of time before that connection resumes. However, Dejero is very focused on the enterprise segment. So we're very focused on applications like oil and gas, mining, utilities, water treatment facilities, transportation of SCADA sensors or SCADA network information, video surveillance, high definition, making sure that there's not buffering within the video quality that would impact video analytics. Facial recognition or license plate recognition software if it's a Department of Transportation type application. And so, from our perspective, Starlink is great in the sense that it provides us with connectivity just about anywhere in the world. But one of the challenges that we've observed is that you may be at a fixed location with your water treatment or your mine, but for those types of enterprise applications, they're typically looking to install cybersecurity type solutions, so VPNs and firewalls. Well, you might be at a fixed location for your enterprise use case, but those Starlink satellite connections that are up in the sky, those satellites, they're still orbiting, they're moving around our planet on a continuous basis. And so what we quite often observe is every now and then, you know, a Starlink or a OneWeb or an Iridium satellite, even in the LEO space, will actually, you know, have a drop, or they'll have a micro outage, so to speak, where they miss the handoff from one connection to the other. Well, that might, for the residential user, result in a 1 to 3 second outage, which is, you know, completely negligible. But for the enterprise customer that has a VPN or a firewall, that means we run into tunnel flapping issues where the VPN may take, you know, 30 to 90 seconds to, you know, sort of re-authenticate and go through that handshake mechanism before SCADA information can be uploaded from that rural or remote location, or before video surveillance information can be uploaded. So we have a customer of ours on the southern border that is uploading video traffic over a Starlink terminal. And what they realized with their VPN connection was they were seeing around 5 to 6 micro outages an hour on Starlink alone with their VPN. When they plugged in the Dejero box in with the Starlink, we aggregate the bandwidth from the Starlink terminal along with, you know, AT&T, Verizon, and T-Mobile. We work with multiple connections. And so essentially, if we observe a small micro outage on the Starlink or OneWeb satellite, you know, service, we simply just aggregate the bandwidth or fill in the gaps with cellular networks so that we have a seamless failover and avoid the VPN dropping out or becoming disconnected. The network traffic continues to flow from that video camera at the edge back to the video management software that might be residing in the cloud, and connectivity stays resilient throughout the connection, regardless of what those LEO satellite connections are doing up in the sky.
So essentially, I guess what you're saying is, A, enterprise customers, they're going to pay anyway, but B, you still require some kind of backup from cellular to a certain extent. It can't, but I mean, like it can't be, you know, we're not talking about somewhere that's so isolated at the moment anyway, where there's no cellular coverage and you're just depending on LEO, unless you've got like multiple LEOs that you can move to.
Exactly, yeah. So from Dejero's perspective, we're all about multiple connections, but they can be multiple IP connections. So it doesn't have to be, it could be a LEO, MEO, GEO satellite that we're aggregating and blending together. It could be a microwave connection from a microwave vendor that we're plugging into our box. All of our gateways and routers have cellular modems because cellular is the most ubiquitous wide area network that's available to us. But if we're truly in a rural and remote location, like, you know, the picture behind me, then we would just use a combination of Starlink and OneWeb, or, you know, OneWeb and Intelsat, or, you know, there's a number of combinations that we can tie together here. Our software works seamlessly from that perspective, but it's all about blending multiple connections together to provide enterprise customers with that resilient connectivity they need. Because at the end of the day, if we're talking about SCADA sensors, it's not a lot of information that we're uploading, but it's typically like, you know, temperature, pressure, you know, leak detection. But if you're an oil and gas customer and you have a sensor, a leak detection sensor that's going off, and that misses a connection for, you know, 90 seconds because Starlink has a micro outage and your VPN is re-authenticating, 90 seconds is a long time for your SCADA sensor network not to be reporting in. And that can lead to some pretty devastating consequences if that leak detection circuit isn't responded to immediately.
Cool, thanks.
Yeah, I'll give Ian the chance to jump in now as well, because I know you wanted to say something.
Yeah, thanks. I've sort of got questions for both of you actually, but maybe just starting with James as a sort of continuation of Rudolph's questions. Apologies, James, I'm not that familiar with Dejero, but it sounds like you're a sort of aggregator of connectivity. I mean, does the does the customer have a relationship with the operator, the satellite operator, or if it's not a satellite operator, with another connectivity provider, or do you sort of handle all of that for them?
So Dejero is probably the most flexible company I've ever had the opportunity to work for. So with that in mind, I mean, we sell a connectivity service that we call our smart blending technology. We have these gateway boxes that have the multiple cellular modems built in. But then, we have the ability to resell satellite airtime and services through vendors like Starlink or OneWeb that will plug into our boxes over an Ethernet cable. However, if customers already have an existing Starlink, if they already have an existing OneWeb connection, if they take an Ethernet cable from that satellite dish and plug it into our box, within about 45 to 60 seconds of having that Ethernet cable attached, our software will recognize that we have an additional WAN channel available to us, and we will aggregate the bandwidth and monitor the quality of service of the Starlink connection, in addition to all of the other wide area networks that we have available to us, whether there's 1 bar of AT&T, 1 bar of T-Mobile, 1 bar of Verizon. We can aggregate that bandwidth to give customers 3 bars of connectivity. And then if we add in a Starlink or a OneWeb, that gets us to 5 bars of service, that now we have a lot of connectivity, we can provide a lot of bandwidth and a lot of value to enterprise customers that are operating in very rural or remote parts of our country.
Are you aware of anybody else doing anything like that? I mean, do you see competition from other people trying to address that opportunity? Because it's not something I've heard talked about much before, to be honest.
We see a lot of competition in this space, but not with regards to how our smart blending algorithm works. So we see a lot of legacy redundancy solutions, such as cellular failover or cellular bonding techniques. But we feel that with cellular failover, you're still susceptible to the tunnel flapping that would occur with the VPN being disconnected and re-authenticating as that cellular failover takes over. Cellular bonding techniques are similar to us in the sense that we both aggregate bandwidth from all of the wide area network connections that are plugged into our solutions. However, I think the thing that makes Dejero unique compared to cellular bonding, legacy redundancy solutions, is that we are actually breaking the data flows that are plugged into our box into small packets and simultaneously streaming those packets over the multiple connections or networks that we have available to us. So we don't do packet duplication across these networks. We're trying to be efficient from like a data management or data plan perspective. We're only sending each packet over the various networks once, but we're capturing the quality of service. So the jitter, the latency, the packet drop over all of those connections that we just sent packets of information across. We resequence and stitch those packets of information back together at the endpoint, but now we know the quality of service on all of those connections on a real-time dynamic basis down to the millisecond level of resolution. So if one of the wide area networks happens to have a micro outage, or there's a fiber cut, or there's a drop in service or network issue with one of the mobile network operators, within a millisecond, we're pivoting that network traffic off of the network that has an issue and onto one of the other networks that is still more reliable and resilient. And that's what makes our overall solution beneficial or differentiated compared to some of the legacy cellular failover or bonding solutions that are out in the market. Of course, every customer has a different set of criteria that they follow. And so that's where we quite often see lots of competition in this space, but we feel that we have a very differentiated technology.
Thanks, Joe. Yeah, maybe just ask David something, Alex, and then I'll let somebody else jump in. But David, sounds really interesting. I mean, orchestration itself has been discussed for quite a long time in the industry and in terms of mobile networks. And I'm just wondering whether this is something, when it comes to working with NVIDIA and GPUs and that whole sort of AI RAN thing that it sounded like you were alluding to, whether you feel that's sort of been a little bit neglected by the big names in the space, and that's where the opportunity is for what you're doing?
Yeah, just bear with me 2 seconds. Alex said I could show a slide, so I'm going to show two. And the reason I'm going to do this is that the term orchestration goes back to the introduction of SS7 and then SIP and all that. So I'm gonna show you. Can you see a slide?
See where there should be a slide.
You see where there should be a slide?
Here we
Yeah,
go.
it's arrived. It's arrived.
You do see it now?
Yeah.
Okay. So what do we mean by orchestration? This is, in sort of networking terms, application layer and orchestration. So what we don't mean is orchestrating the actual, packet routing and call establishment, call following, tear down, and all that. This is a new thing that doesn't exist. So we're building for the future where everything's got intelligence and is continually connected via wireless. I do want to mention also, we're not opposed to satellites at all. It's just where we are putting or going to put the technology is going to tend to be co-located, with the cellular infrastructure, because we have no way to load code into a Starlink or Kuiper or OneWeb satellite. So maybe someday it would make sense to do that, but not this week. So what you're seeing on the screen is we do have this incredible number of autonomous machines coming at us. And the issue is, well, how do you get the bipedal robot to stand up, go out the front, pick up a package from a delivery device that rolls up on the street and authenticate, and then there's 12 of those delivery machines rolling around the neighborhood, and when they get done, they all go to a van that is there to collect them and then take them to the next neighborhood. And on board the van, there's a robot that's loading them with the new delivery items. And that all sounds fantastical, but it's already happening on a sort of a fixed basis where, Amazon does now have robots they're testing in their warehouses to load their delivery vans. And part of the reason they've been transitioning to the Rivian all-electric vans is they're bristling with sensors, very nicely concealed, by the way. And those will eventually become fully autonomous. So that is the plan. And they also have Zoox, autonomous passenger delivery, that's also part of Amazon. And those things are actually sharing data already. So with that being said, I'm going to just show you real quick from a very lightweight topographical standpoint. Strata is the name of our brain for the system. And the really important thing is that something's moving into or out of a cellular coverage area, and the system has to say, oh, I know what that is. I'm transceiving data with it. I may be performing any number of operations that are better done in that fixed server array because there's not enough power on board the machine to do it, or the machine doesn't have access to the data. So this isn't just about data routing. There's quite a lot of intelligence there that has to do with policies for where the data can go, legal, liability, financial, tariffs, even micro tariffs crossing borders, all have to be taken into account in this backplane. So a pretty good analogy might be, I think what James is talking about is really cool stuff. When we're, if you would say that is sort of like in the telcos as well, that's kind of like the railroad and laying the tracks, and we're providing the actual trains and the depots. So there's a huge number of large companies, pretty keenly interested in this, and but really, to repeat, this is nothing people are really asking for yet. This is kind of, since James in Canada, I'll use the hockey analogy of Wayne Gretzky saying, I just skate to where the puck is going. And that we're trying to anticipate where the puck is going with this technology.
But it sounds like you've worked quite closely with NVIDIA on it. I mean, is it sort of built on NVIDIA's platform, what you've done?
Well, first of all, NVIDIA is kind of a new thing for us. We haven't, they're not writing code. That could happen, by the way, but not right now. The idea is that we have built this. I could send you the deck, but the first phase we're in isn't what I just showed you. That's what's called phase 3. Phase 1 is called supervision. So supervision is we realize that with almost no exceptions, any intelligent moving machine in the future will be fully electric, not a hybrid, not a petrol, fully electric. And there's a lot of physics reasons for that. So if you know that that's almost certainly going to be the case and it's full of electric motors, then we have to make electric work better. So even though it's more of a problem in the States and Europe than say China right now, so we decided to roll up our sleeves. And the first application of this technology is to help make EV charging infrastructure work a lot better, get it up to much, much higher levels of reliability and frankly, better experiences. And so we're working on that. And then the next phase is synchronization, where we synchronize vehicles with charging networks and other infrastructure, things like microgrids. That's really, really interesting. We could have a whole seminar on that, but the only company really doing synchronization at any kind of scale is Tesla. If you plug your Mustang Mach-E into the Tesla network, which you can now do, that's fantastic, and it tends to work. But if you're in an actual Tesla vehicle, there's a continual dialogue between the vehicles and their system, which they've been using AI well before he created XAI in the Tesla infrastructure. So it knows everything about your vehicle. Where are you on the earth? Even the topographics of the terrain, what's the weather, your state of charge, are you a light foot or lead foot? And then it'll figure out, well, if you stay on this vector of travel, they're going to run out of electrons in, say, 80 kilometers. And it'll say, no problem, but there's a Tesla supercharging station in 30 kilometers, and it'll guide you there. And the new thing they're doing, which is part of why synchronization is really useful, is they can actually reserve an individual charger at the charging station for you and say, Alex, you're going to be there in 10 minutes time, and at 5 minutes, we're going to lock out charger 4 for your Tesla Model Y. So they give a lot of love to the Tesla vehicles because it's all in the family. So we kind of approached that and said, well, what if you could do that for everybody? And of course, that turns it into an n times n minus 1 complexity level, which has a lot of reasons why machine learning is useful. So our next goal will be, and it'll start with commercial customers like big fleet operators who would like to have that, and a lot of business relationships are probably harder than the technical ones. And then you get to the sort of the holy grail, which is live orchestration of everything. I'll give you one quick example and then stop. Especially in Europe, there's a technology being tested a lot that's called platooning. I have no idea why it's called that. It doesn't remind me of anything in the military per se. But you take a bunch of lorries and string them out, and there's currently there'd be like a guy driving the lead one, and all the others are following like ducks. And somewhat similar to Australian land trains, except that there's
it is called a train.
yeah, I know, but they call it a platoon. I would call it a road train. Yeah. So the ones that are in Australia are really amazing, but they are coupled together, and the lead tractor unit is pulling them. These are all individually powered. If you can imagine, and we've been speaking to the newly refurbished U.S. Department of Transportation, they envision that eventually the high occupancy vehicle HOV lanes on motorways will be converted to fully autonomous lanes, and you can't be in that lane if you're literally driving the machine. So having a bunch of vehicles platoon, which has a lot of really is really about efficiency, and there's just not enough drivers, so it solves that quite a bit too. It's helpful if all the lorries belong to one company and they're all going from one place to another, but that's not the real world, and you may as well use an actual train for that. So the idea is that you create ad hoc platoons where there's different machine types, different ownership, and so on, and they just kind of forms and goes into that lane. And your drafting, which is what platooning achieves, gives an average of 15% efficiency gain, just like it does in motor racing. So it's pretty cool. So anyway, again, it's sort of like air traffic control. You could have individual towers and aircraft, but when they start moving between each other, you needed something, and that became air traffic control. And probably the best analogy to orchestration for physical objects would be air traffic control, if I'm being honest. So anyway, I don't know if that helps.
No, I've got that's really interesting, and I think everybody can visualize what that would look like. And I hope a few people can also wonder why you wouldn't just invest in better public infrastructure and canals. I think, like, I know you said that everything's electric, but ultimately, that's a slightly different conversation. But my question is around data, because if you're using AI to orchestrate these things that can, right, if you take your platoon of trucks, right? If that goes wrong, I mean, that's really a disaster to everybody else on the motorway. And so what you really need is it's from the beginning, really clean, really well curated data, but you need that continuously because these are self-learning, self-optimizing models that are continuously taking data in. And so what kind of systems do you have in place, or do you envisage that would kind of like validate that data, so that there's nothing harmful going in? And you can easily imagine, bad actors, whether they're state-sponsored or not, attempting to pollute that data on a continuous basis. And so, what do you do with that? Because I think that with a lot of things with these about this data security is going to be an increasingly large problem, and I imagine it'll be one for you as well.
I love that, because you're getting into the what we call the boring but vital portions of what we're developing. I mean, it's not sexy, so nobody talks about it. I'm really glad you brought those up. So I'll try to be efficient. So one, the analogy of air traffic control is pretty good, and the reason is that air traffic control, at least at the moment, is not actually flying planes, right? The planes have some form of onboard intelligence called guys in uniforms in the cockpit. Then you have some form of autopilot, and of course that's getting better and better and better. It's kind of amazing nowadays, between Airbus and Boeing. But with that being said, air traffic control is not running the operation in real time. They are trying to get to that because they want to add the drone layer below 400 feet, at least in the US, which is the domain of the FAA ends at 400 feet above ground level in the US. And there's this huge thing about trying to deal with that at the Department of Transportation. That being said, drones, you need a little more real time, but in big aircraft going, however many kilometers per hour, subtle microsecond changes don't matter, unless you're doing a collision avoidance, which will be done on board, like a jet not hitting a B-52. So I think so that's sort of highest level answer is, in a lot of cases it wouldn't be real time in the sense of instantaneous, but the data is transferring continually. So now I'll get to the real answer. We put a lot of effort into this thing called the policy engine that uses machine learning to kind of absorb what are all the issues that have to be dealt with vis-a-vis the movement of data, storage of data, and glibly we call it the policy engine. Allows you to control who can do what to whom, when, where, why, and how. The technical version of that is 3 paragraphs. So but the really important thing about it is the originator. We decided the originator of data would control the routing, if you will, of that data. And this again isn't routing like a Cisco or Juniper. This is, you know, wholesale level, if you will, like we're moving all the data pertaining to that origin point. And it even takes into account who owns the machine emitting the data, which may not be the same as who owns the rights to the data. And there may be legal issues. And so, and then the other one on the side of what you're talking about is liability, which is something everybody's starting to figure out is going to be huge. So, you know, a Toyota sends, if a data from a Toyota goes to a GM vehicle and it says, hey, I just went over a pothole back there. And then either because the data wasn't complete or because of the way it was processed on the General Motors end, or whatever it is, there's an accident leading to damage to property and or loss of life. You can imagine the lawyers are going to be, you know, have a field day suing these very deep pocket companies. It is already happening with Waymo because it's part of Alphabet, Zoox because it's part of Amazon, Tesla, you know. So that whole, we have some really heavy duty insurance executives involved. And then I'll end that with the security, cyber security. So we realize this is such a daunting cybersecurity problem from many aspects that I'll just say we have some former NSA people involved with the design, and they're just terrifying. So,
and famously, the automotive industry were pretty good at falsifying data.
I know, yeah, well, yeah. So yes. One thing I'll mention, though, sort of tagging on that, I just realized you might find interesting, EV infrastructure. So people don't realize that these DC fast chargers, one, they're incredibly expensive. They're not the ones you hang on the wall of your garage. That box you see, probably the slimmest would be the Teslas, but they also have a bunker that you don't normally notice that has a lot of the stuff going on that's cabled to the individual dispensers. But none of the manufacturers seem to give a lot of thought to cybersecurity when they started building these, and yet there is usually full of processors. So this is almost funny, and James, you'll really smile when I say this, I think. So IT professionals love shortcuts, love it. They love things that are easy. They love, you know, scripts and hotkeys. But the other thing they love is, you know, it's a hot day or a cold day, and I really don't feel like getting out of this van or pickup truck and configuring the charging unit. So when they first install them, they leave the wireless ports. I'm not talking about the cellular connection to the network. I'm talking about Wi-Fi, Bluetooth. Most of these have standardized motherboards in them, so they have those ports on, and then they can just literally sit in the vehicle with the aircon running and configure the charging unit. Well, they leave those ports open. There's so many cases like this now that I'm almost quoting them. They leave the ports open because otherwise, if you come back, you have to get the keys and open the cabinet and turn, you know, maybe plug an Ethernet cable or whatever. So what's happened, and there's some really serious cases that have already happened. They don't seem to get very publicized, but for some reason, but somebody will pull up, maybe it's a former employee, and they just pull out their laptop and just get into the charging unit. So a company that may or may not be affiliated with a company you were thinly veiled reference to falsifying data that built a charging network in the United States. Just say that. Somebody pulled up, and there's nobody, most of these, there's nobody watching these things. You know, they're often not where there's a lot of humans. And they hacked in and realized that because nobody had firewalled it properly, they could get all the way into that company's headquarters in Michigan for the US, and then they figured out how to somehow get from there to Germany. So from one port, they're actually, and they're like in Minnesota or something, they're actually able to go all the way into a very, very large automotive manufacturer and hack their way around. So anyway, I just gave you that story because it's just kind of good to have in your mind. You know, when people are building this next generation infrastructure and edge, I'm sure you're aware that Starlink has been hacked a lot from, you know, the quote opposition to the Ukraine, who have very good hackers. And so that stuff is, you know, with Internet of Things and moving machines and all that is, you know, we have to really, really worry about that. And unfortunately, it does slow things down, and it has to add overhead to processing, but you need to do it.
That's great, thank you. And I have a question actually for both of you, David and James, if that's okay. You know, what you're doing is thoroughly exciting, and it feels like this is something where these are potentially natural extensions of what telcos do, or should be if they had their act together. And so I'm really curious as to how you find that fit. I mean, is that because there's something you're better at doing than if you're like the established telcos, or you know, what's the secret sauce there, do you think?
James, what?
Yeah, I think from our perspective at Dejero, you know, these network operators are pretty good at what they do. You know, their networks don't go down all the time, but when they do, it becomes headline news. You know, we've got a slide that has clips from, you know, the Wall Street Journal or USA Today that highlight when AT&T or Starlink or Verizon has a network outage. It makes headline news. It doesn't happen all the time, but when it does, and you're an enterprise or you're a critical application, that's where having Dejero on board, if there's a network outage, you know, many users may be impacted, but you know, if you're a Dejero client, you may not even realize there was a network outage because of the way that our software works. So there's lots of conversation in the world about how internet is becoming sort of the fourth utility. But unlike heat, light, and hydro, if you're relying on a single connection, you're sort of at the mercy of what that internet service provider is going to provide you in terms of network resiliency, reliability, bandwidth. You're sort of at their mercy in terms of what they'll provide. You know, I know a lot of mobile network operators will say, here's an unlimited data plan for your SIM card. But they're not really truly unlimited. You know, you'll notice at the beginning of the month, you've got full throughput, but towards the end, fair usage policies apply and your speeds will become throttled. With Dejero, because we have multiple connections, because we have the ability to monitor the quality of service across all of the connections that are plugged into our box, we can give you control over your internet connection. We can give your customers the ability to say, hey, I've got a really hot deal with AT&T where they've given me, you know, quote unquote, unlimited data for, you know, a very sweet rate. But then, you know, at the end of the month, you know, you're a high bandwidth user, you notice that your network's getting throttled. If we have, you know, Verizon and T-Mobile SIM cards or Starlink, we can just pivot network traffic over to those other connections to make sure that you have a resilient path that gives you the bandwidth that you need for that part of the world that you're operating in, whether that's a rural or location like the one pictured behind me, or whether that's in an urban, you know, environment like New York City. It's very interesting just to see when you get, you know, large events like New Year's Eve in Times Square, how our technology compares to other, you know, failover technologies. Other failover technologies rely on sort of an active-passive combination of cellular modems or, you know, satellite and cellular modems, where you're really only transmitting on one, you know, device at a time. So you're susceptible to things like buffer bloat on network when you've got a high number of users condensed into a small area like Times Square. With Dejero, because we're monitoring that QoS and we're breaking the packets apart, we can be more intelligent about how we route traffic over the multiple connections, and ultimately not only increase the bandwidth that you have in those challenging, oversaturated situations for the telcos. We can also, you know, give you more bandwidth, but reduce the overall loaded latency of the connection by, picking the channel that has the path of least resistance for the network traffic that we want to send when we're in those heavily congested environments like Times Square on New Year's Eve, or music festivals or large public gatherings. When it comes to critical connectivity, that's where our software and our solution sort of stands out and provides people with control over that internet connection that, if they're relying on a single network, they don't have any control over.
I'd jump in, Alex, quickly, because I'm interested in what James just said there as it sounded, James, like you were talking earlier about it being very much for rural users, and you gave some examples of kind of low bandwidth stuff that's essential. But what you were just talking, have you had people approaching you, or have you seen it being used in sort of stadium settings? People going to a Wembley Arena, Wembley Stadium type experience where there are constraints in what you can get over the network because you've got so many people there. Is your technology something that could be used to address that? And is that an opportunity for you to go to those places?
Yeah, absolutely. Actually, I'm just gonna figured out I could share my screen here. I am not familiar with this tool, so to speak, but I'm not sure if that's coming through or not. If I can share my screen. We started in the broadcast video industry as I had sort of highlighted. And so, from that perspective, is my screen coming through? I'm not sure.
It is.
Out of curiosity. It is? Okay.
Yeah.
So we started in the broadcast video industry. So when you talk about Wembley Stadium and you talk about, filming activities for live sporting events, quite often our devices are plugged into the Sony or Panasonic cameras that are on the sidelines, actually broadcasting the high definition video from the sidelines back to the broadcast studio. They may add in graphics for the scoreboard or the ticker at the bottom of the screen, but the raw video transport from the edge to the cloud is where Dejero's business actually started from. But we also have that reporter that's reporting on live breaking news in the middle of nowhere on a natural disaster or something to that effect, where we also need to be able to broadcast high bandwidth information across multiple networks. In terms of the New Year's Eve example, this is sort of what I'm referring to, in that example. Now that I'm able to share my screen, but you can see the Dejero solution in the background there is able to do around 130 megabits per second of download capability, whereas a cellular failover solution is sort of limited in terms of its overall bandwidth. So if we're in highly congested RF environments, our technology actually still really works well, not just in rural or remote, but realistically anywhere we can help solve those connectivity problems.
By the way, a good friend of mine, he's the guy who puts together the on-site connectivity for McLaren F1. And he said that just McLaren uses 5 terabits per second during the races, and they've switched to things like lasers to bounce things over the middle of the course. And it's like, wow, that car generates that much data. So anyway, yeah, and I know we're out of time, by the way. So yeah, and we're very bullish on what we're working on. It's been fascinating, but to really wrap it up in the sense of the telcos, unquestionably the telcos, they've been doing the same thing one way or another for a long time. And the reason I brought up the satellite thing, by the way, is that a lot of them have said like, oh, we're really worried about that. And I said, oh, well, I don't know, but sure. But the important thing is they're kind of looking for a second life for their networks, which is why if you install basically servers co-located with the big cell towers, you fill them with AI, you have an opportunity to start providing value added services that they can ideally charge money for. And you're talking about small transaction fees in most cases, but if you're doing billions of them around the world every day, it adds up to, as they say, real money. So again, we just said, well, we didn't see anybody, including the biggest players, working on that sort of a orchestration layer So it became our mission. But then because, we're venture capitalized, they said, well, that doesn't sound like it's going to be important for a few years. What are you going to do now? And that's why we decided we aim the beam at EV infrastructure. And so with that being said, the EV infrastructure leads to synchronization of and with the vehicles, which leads to everything can happily interact with each other. And then a webinar for another day is we've been approached by a consortium of banks and the big credit card issuers to create a thing that they're calling the autonomous economy, where you give agency to machines so that they can go pay for things, goods, services, software, whatever, without a human in the loop. Is a super interesting concept. But those banks are going through the same crisis, if you will, of like, well, all these, there's a lot that could displace us. How do we remain not only relevant, but have a big part in where it's going. So again, if a big telco anywhere on the planet, it's not just going to be like putting AI in your RAN switches or something. It's going to be new application layer things, just like how smartphones just completely changed the world from just phone calls to it's almost 100% data. So
Fantastic, thank you. And I mean, I've been enjoying this conversation hugely, but you're absolutely right, David. We are coming up to time. So with that, I would like to thank David, James, Rudolph, Ian, and Caroline for their time this afternoon. It's been a fascinating session. I'd like to thank again our sponsors, Viavi, Radisys, DukeWise, SES, and NI. And I'd like to thank you in our audience for joining us as well. If you found value in the discussions today, then do consider subscribing to Telco Forge's regular newsletter Influx, where we're working on as many ways to help the telecoms industry advance as we can manage. But with that shameless plug, thanks again to you all, and goodbye.